In this video, we are going to apply what we know about volumes of solids of revolution to a coffee cup problem. So we know that the volume of a solid of revolution is given by the formula shown over here. Okay, so all we've got to do is set up an integral over a certain interval b and a, and we are going to square the function that we're rotating, integrate it and multiply the result by pi. Okay, I'm going to start with the square root function. Fx equals the square root of x. And I'm going to rotate it over the interval b and a. Now, a is going to, I need a bit of a base for this cup, so I need it to be able to sit up properly. And so when I rotate the curve, I need a base, and by setting the lower limit at a, it's going to give me that base. Okay, I'm going to initially set it to 9. Now why 9? Well, 9 because when I substitute 9 into into fx, I get the square root of 9, which is 3. And I think a coffee cup with a base radius of 3, in other words diameter of 6, is going to be more than enough, and in fact possibly too much. But anyway, it's a good starting point, I think. So what I've got to do is set my volume to equal something. Let's say it's going to equal 300 because I want 300 millilitres, to be my volume. So I'm going to say 300 is equal to pi times the integral of b. We don't know what b is, and this is what's going to be determined. And the lower limit is going to be 9. And then I need to square the square root of x squared. Well, that's easy, that's just x. So I've got this rather easy integral to evaluate. Okay, let's look at another slide before we move on. Okay, so setting up my integral, I've got the volume equal to pi times the integral of b as the upper limit, 9x dx. So the x comes from just the square root of x squared. Okay, now evaluating the integral, 300 equals pi, and then I use my square brackets, x squared on 2, and there's my upper limit b, lower limit 9. My job, of course, is to find the value of b. So moving right along, we've got 300 on pi, so I just divided both sides by pi there, equals, substituting b into my integrand here, we've got b squared over 2 minus 9 squared over 2. Okay, that comes down to, what have I done here? I've multiplied through by 2, so 600 over pi. I'm clearing the denominators on the right hand side, equals b squared minus 81. And adding 81 to both sides and taking the square root lands me here. So it turns out that b would equal 16.59. Now, what have we actually found here? Well, the base was set to equal 9. 9 what? Well, 9 centimetres. Sorry, the base wasn't set at that. The interval was. So the base is in fact going to be this length here, which is 3. Okay, so when I rotate this function around the x-axis, the radius is going to be 3 and the diameter 6 will be the base of my cup. Okay, so we are saying the upper limit will be, if I want 300 mils, will be set over this interval, and here. So when I rotate my function around the x-axis, this will be 16.49, and that will yield a volume of 300 millilitres. Sorry, I might not have said that correctly. And that means the height of my cup would be 16.49 minus 9 centimetres. Okay, so that's a point to start at. I'm not sure it'll be the ideal coffee cup, but it certainly would give you a feasible solution. Thank you for listening.